Okay, now quickly what I just said. You got this polynomial. Its zeros occur when this expression is equal to 0, which can only happen if this is 0, or this is 0, or this is 0, right? So, when is this 0? Well, when x plus 5 is 0, that happens when x is negative 5, right? So that means you have the point negative 5, 0 on the graph of your function. So this is a point on your graph. Okay? And when's x minus 2 equal to 0? Just when x is equal to 2, right? So x minus 2 equals 0. You just write it down as an equation, add 2 to both sides, solve it. Sometimes you have to do a little more to solve them. These are real easy to see. But anyhow, it's x equals 2, right? But whatever's here, you just set it equal to 0 and solve the equation. Okay? And then x plus 6 equals 0. Yeah, if you solve the equation, you get x squared equals negative 6, which means x would be what? Plus or minus. You keep leaving off those pluses or minuses. You need to pick up on that. But plus or minus the square root of negative 6. The square root of negative 6 isn't real. You don't really need to do that. All you got to really do is understand, well, x squared can't be negative. So when we add it to 6, it can't give us 0. Okay? So, you know, you can do that just by looking at it, if you think about that, because it's not hard to understand. But if you have to write down x squared equals negative 6, go ahead. You're going to get a square root of negative 6, even if you forget the plus or minus. Okay? And you're going to find that it can't happen. So there are only 2 zeros. Now, if we didn't have the x squared plus 6 there, we would have a parabola. Because you know when you multiply these out, you're going to get a quadratic. It's going to be a parabolic graph. And its vertex is going to be halfway between the zeros. Okay? And you're going to be able to plug in and find the vertex. And y'all are pretty good at that. Okay? Even people that didn't do very well on the test often got that. So, and that's you know, that tells me that you know, looking at the test, I don't see any evidence that anybody's stupid. I see evidence that people didn't learn their algebra well enough, but that can be fixed. And I see evidence that people haven't put enough work into the course, and maybe there's still time to fix that. Okay? But I don't see any evidence that people can't do this. And every one of you, and everyone who's not here. Okay, so anyhow, this is what we got. Now, this isn't a parabola because we're multiplying by x squared plus 6. Okay? We'll probably still have something like a vertex somewhere close to halfway between these. But multiplying by that x squared plus 6, the value keeps changing, and that shifts things and distorts them. You don't need to understand that, but some of you will. So if you do, it's even better. Okay, the point is that then the graph of this function has to go through this point and this point. Also, it's not 0 anyplace else. There's any other value of x will not make any of these 0. We've got all the values of x that make any of these factors 0. And if none of these factors are 0, you can't multiply 3 non-zero numbers together and get a 0. I said that last time, so I'm not going to belabor it today, but I'm just kind of trying to refresh the idea. Okay, so the graph has to go through here and here, and it can't go through the x-axis anywhere else. Because if it did, there'd be a 0 at that point. The graph can only go through the x-axis if the y value is 0. If there's another point where it went through the x-axis, that means there's another x value that makes y 0, and there isn't. Okay? That's an important point to understand. Now, we need to figure out whether the function is positive or negative at different places. Okay? Because when you get more complicated functions, it'll go positive, negative, positive, negative, positive, positive, negative. Okay? Do that all the way across the x-axis up to a point. So you have to know what to do there. And of course, I told you last time, gave you problems that ask you to do that, and hopefully you at least made some good progress on them. Okay. This means that P of x can't change sign on the interval from -5 to 2. Why not? Well, because the function is smooth and continuous. And in order to change sign on an interval, you have to go through the axis. If you go from negative to positive, you got to go through the x-axis. If you go from positive to negative, you got to go through the x-axis. Okay? Since it can't have a 0 between here and here, we figured that, we proved that. It can't go through the axis here, so it can't change from positive to negative, and it can't change from negative to positive between here and here. Okay? So, okay, at x equals 0, why do I choose x equals 0? Well, I'll explain that if I need to. I assume that I need to for some. X equals 0, what's the value of this thing?
Negative.
Negative what? Well, there are three numbers you would multiply to get the value. What are the three numbers? Huh?
Negative 60.
Negative 60, yeah. Because if x is 0, x plus 5 is 5, x minus 2 is negative 2, and x squared plus 6 is 6, right? So P of x start over on starting map. Well, you can write it out if you need to. It's okay. But if you write it out a couple of times, you're not going to need to much anymore. You'll see what happens. So P of x equals P of 0. You plug 0 in for x. You get this, which is 5 times negative 2 times 6, which is negative 60. Okay? Now what conclusion do you draw? P of x has to either be positive or negative all the way from negative 5 to 2, right? Is it always positive or is it always negative?
Always negative.
I'm sorry?
Negative.
Always negative, and why?
Because it hasn't passed.
Well, because 0 is between negative 5 and 2, and when x is 0, it's negative, right? If it's 0 at one point, or if it's negative at one point, it has to be negative at all the points in that interval, because it can't change sign. Not between here and here. The only places that function's value can change sign, can change from negative to positive or positive to negative, is here or here. That's it. Okay? So, P of x is negative 60. Zero's in the interval from negative 5 to 2. So P of x is negative on the interval from negative 5 to 2, right? Okay, well, now the way I'm going to write this, I'm going to say, okay, if x is 0, I don't really care what the numbers are. If x is 0, is this positive or negative? X plus 5. If x is 0, x plus 5 is clearly positive, right? and x minus 2 is negative, and x squared plus 6 is positive, right? So really all I have to do is, I'm going to write shorthand plus minus plus. Now say, I'm writing it small, but this says x plus 5 is positive, x minus 2 is negative, and x squared plus 6 is positive. So I got positive, negative, positive for this term, and this term in order, right? That's going to be a shorthand that I'm going to tell you to write down. You know, your first problem. You got a function. Okay, I think it's got 3 factors. You just write down plus, or minus, minus, plus, or whatever it is. Okay? You reason it out. And you write it out like this, and you don't skip steps. Okay? One thing that causes people not to learn stuff is skipping steps, which means you might well be invoking superstition to do your mathematics. Superstition is not a good thing to invoke pretty much anywhere. Okay? But in mathematics, it's really fatal. Okay? Now, if you have a plus, a minus, and a plus, and they're multiplied, you get what? 2 positives and a negative give you a negative, and we know that. So I'm going to write down here, and just to emphasize, I'm going to write it below the axis with a big circle around it, indicating that between here and here, this function is negative. Okay? Then, okay, if x is bigger than 2, now we could pick a number bigger than 2. And sometimes we need to do that. You know, probably pick 3 because that makes it is about as easy as it could be. Or maybe we pick 10 because it's a round number. I don't know. Or maybe we pick 1,000 because it becomes really obvious whether each term is positive or negative if you pick a great big number, right? But I'm just going to say x is something bigger than 2. Now if x is bigger than 2, is x plus 5 positive or negative? Yeah, if x is bigger than 2, then if you add something bigger than 2 to 5, you're going to get a positive number, right? Okay, what about x minus 2? If x is bigger than 2, what can you tell me about x minus 2?
Positive.
It's still positive, right? You add something bigger, you subtract 2 from something that's bigger than 2, you're going to get a positive number. Now if you're not sure about that, say, okay, let x be 3. 3 minus 2 is 1. Yeah, I was right. Okay? Make sense? And of course, whatever x is, when we add it to 6, it's going to be positive, right? So now we know that here, anytime x is greater than 2, we got positive, 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 which means we've got a positive result on this interval, right? I'm going to write that in a different color. And I'm going to put a big positive here, and I'm putting it above the x-axis to remind myself that that's where positive values of y live, above the x-axis, right? Then I'm going to come over here and do the same thing. Now on this interval, x is less than negative 5, right? If x is less than negative 5, what do I get if I add something that's less than negative 5 to 5? Well, you can reason out pretty easily that's negative, but if you're not sure, just let x equal negative 6. Okay? Negative 6 plus 5 is negative 1. Okay? So you can't follow the first line of reasoning. And yeah, that can be a little tricky until you get used to it. I'm just fine if you just pick negative 6. Okay? Okay, now if x is less than negative 5, well, it's negative, right? Anything less than negative 5 is negative. And if I add anything negative to negative 2, I'm going to get a negative, right? So this is negative. This is negative. This is always positive. I square a number, whether positive or negative, I get a positive number, right? The smallest thing I can get for x squared is 0, and if I add that to 6, I still have a positive number. So now I know that on this interval, I have negative, negative, positive. Well, if I multiply a negative by negative, it's going to be positive. If I multiply that by a positive, it's going to be positive. So I'm going to put a big old plus over here. Make sense? Okay. So I know this much about the graph. It's above the x-axis on this interval. Okay? And that's what? How would you write that in interval notation? Well, that is negative infinity 5. Okay? So all the way from negative infinity up to 5 is positive. Now when we get to 5, it's 0, right? So it's an open interval on which it's positive, because it's 0 there. And 0 is kind of neither positive nor negative. Okay. Now on this interval from here to here, and it's an open interval, we've established that the function is negative. And of course, I've already written the interval, but this is the interval negative 5, 2. And on this interval, it's back to positive, and that's the interval 2 to infinity. Now, does all that make sense? Hopefully. Okay, if not, well, you got 18 minutes of me to listen to, or you can look at something else. Okay? Or, you know, go ask somebody. But there it is. So, we got a lot of information about the graph, but there's a lot of ways this graph could be drawn. Okay? Like, it's positive over here. Well, what does it do? Does it wiggle around here and go way up here and down here and way up here before coming down to 0? And then what's it do down here? Does it suddenly become a straight line and then another straight line up to here, or does it come down here, wiggle around, try to get to 0, and then come back and finally get to 0? And then how does it go positive here? Does it do this? Does it all of a sudden get steep and just take off for infinity? What's it do? Okay, so let's talk about that.